Bhagya is a final stage PhD candidate in economics at the University of Queensland, Australia. She is a passionate researcher in applied economics, where her primary interests are in the economics of education, experimental and behavioral economics, labor economics, and gender economics. Her research currently focuses on the peer effect in education, where the role of peer ability, incentives, information, and gender are investigated using experimental and quasi-experimental methods. Having presented her work in applied economics at many conferences, she was awarded the best presentation at the 36th PhD conference in economics and business held at the University of Western Australia. She received the Dean's Honour Roll in recognition of academic excellence while completing her Master's in Advanced Economics at the University of Queensland and has obtained an MSc in Financial Mathematics at the University of Colombo. She is a proud alumnus of the University of Kelaniya, having completed Bachelor's in Special in Statistics and receiving the Gold Medal for the best performance in statistics. So with great pleasure, I would now invite Bhagya Gunawardana for the second lightning talk. She'll be speaking on the topic, same gender peer role models in education. Over to you.
Right. Hopefully you can hear me. Give me a second.
Yes, we can hear you.
Can you see my screen as well?
Yes, we can see your screen as well.
Well, thank you so much for the opportunity to present here and be a part of this great event. And I recently completed my PhD, and this is one of the projects in my dissertation, which is same gender peer role models in education. And this is a collaborative work with Sophocles and Regissa. Before I start, I want to emphasize that we listened to many great talks today and yesterday, which give the hint and insight that we really need role models sometimes to promote underrepresented people in demanded fields. So I hope through this project, I can add some more value to those talks and inspire you as well. So let's begin. I will start with the motivation behind this study. So we know in many countries, females are quite underrepresented in STEM fields. And as you know, when I say STEM, we are referring to the fields in science, technology, science, engineering, technology, and mathematics. And this underrepresentation of females accounts to a significant portion of gender pay gap. I mean, I'm pretty sure that we all have heard females are under earning than men. So it's quite interesting as well as important to understand why females are not choosing these highly demanded, highly paid fields. So in 2017, Microsoft Corporation undertook a survey in Europe to understand why females are not choosing these fields. Based on their report, girls reported that lack of role models in STEM as a key reason why they did not choose a STEM career. Well, we talk about role models. Who are role models? So generally, role models are considered to be people who we looked up to and consider as worthy of imitation. Well, for example, role models can be some highly successful external speakers or the speakers like we see here today, or parents or teachers or even peers. So in this project, we asked the question, can same gender peer role models mitigate the gender gap in STEM? Well, however, when answering this question, we encounter several problems. One is that high achievers in peer groups are not necessarily considered to be role models. Secondly, but most importantly, the selection bias issue. So the selection bias is that students can self-select into peer groups depending on the members in the peer group or the high achievers in the peer group. With the selection bias, it makes it difficult for us to make any causal inferences of the treatment. Well, then the next one is that how do we answer this question with these issues? Well, for this study, we use a very rich and novel Greek high school data set, which is coming from my co-authors. And we focus on the top performer. More specifically, we focus on the gender of the top performer. So in this Greek high school system, top performers are explicitly recognized by their teachers as well as their fellow peers. And in Greek high school system, the students are allocated to classrooms quasi-randomly, as well as the top performers. I will explain how this happens in this high school system in a second. And in this study, we investigate the effect of gender match between the top performer and the other students and investigate the effect on educational performance and outcome. So what's new in this project? This sounds quite familiar. So in this project, we consider internal role models. So this is beyond the existing studies on external role models. And why is this important? Because internal role models, if you can identify internal role models and if you can find any effects in there, this can be a very cost-effective way to implement and easily scalable as well. Secondly, in our study, the top performers do not involve in any teaching activities. So this is beyond the current studies which study the effect of the gender match between the teachers and students or the lecturers and students. This is important because with the teachers and their gender, they might change their teaching strategies. So this can confound the treatment effects of the gender match. Thirdly, we consider the top performers that we consider in our study are chosen based on an exogenous role. So this is beyond the current emerging literature, which focus on the peer role model effects of having a high proportion of high achieving male or female students in a class. Well, then, okay, now I'm going to explain the institutional setting and how this top performer is recognized in the classroom. Well, in Greek high school system, every subject teacher marked the attendance. So this is quite different to Sri Lankan system, at least at the time that I went to school. So in Sri Lanka, we generally mark the attendance once a day. But here, every subject teacher marked the attendance. So every subject teacher come to the class and ask for the attendance book. Then the record keeper bring this record book. So this happens several times a day because they have to take this attendance book or the record book to every teacher in every period, every day throughout the semester. And so consider this top performer or the record keeper as the monitor in our schools. So, however, this record keeper by law in Greece is the top performer in each class across all subjects. So it's not by vote or anything, but it's by law that this record keeper, the one who takes this record book to the teacher, is the one with the highest average score across all compulsory subjects in their first semester exam in grade 10. And this record keeper stays as the record keeper until the end of grade 10. Okay. Then, so in Greece, grade 10 to 12 is considered as high school, and grade 10 is the general education. So at the beginning of grade 10, that's when they start the high school, they are assigned to classrooms based on their last name. That means, say, if you have a last name starting with A, you will be in grade 10A or 10-1, like classrooms with earlier class number. And if you have a last name with a letter, then you will be in a class number, like higher number of what you call like letter classroom number. Then the top performer is selected based on their first semester exam and the one with the highest score of the all compulsory subjects. Then at the end of grade 10, students make a very, very important decision. That's the track specialization decision. In terms of Sri Lankan system, let's think about the A-level class. You need to decide what to specialize on. In Greece, there are 3 track specialization decisions. Either you can choose science, IT, or classics track. In this study, we consider science and IT as a STEM track and classics as the non-STEM track. So this is the very first instance that students make a decision on what to specialize on. Okay. Then in grade 11 and 12, students need to undertake core subjects which are common to all tracks. So regardless of the track that you are specializing in, you are undertaking these core subjects in grade 11 and 12. On top of it, they need to undertake these track-specific subjects. So they are different across tracks. Then at the end of grade 12, they undertake a centralized examination process for the university entrance. One more thing, that after students are allocated to classrooms at grade 10, they need to stay in the same classroom, that means with the same set of peers throughout their high school years. So they can't change the classes. Well, then, so from where do we get our data? So this is a map of the grades, and the areas where we highlight are the counties from which we get data. So we have data from school archives of 105 schools, which is approximately a representative sample of 10% of public high school population in Greece. Then we have administrative data from the Ministry of Education for the whole country for 2003 to 2011. So this includes students' decisions on which university to apply, whether they were successful in getting into that university, the quality of the university, and etc. So for the analysis, we merge these two data sets and focus on the match sample of 105 schools. So after we merge, we have altogether more than 55,000 observations. Okay, so how do we estimate the effects? We use a simple equation. This is the equation that we estimate, and we do estimate this equation for males and females separately. So y is our dependent variable, and we have a constant, and our main variable of interest is the same gender top. So this is a dummy variable, which is equal to 1 if you have a same gender top performer, and 0 if you don't have an opposite gender top performer. So for example, consider if you're a girl and your top performer in the class, or the record keeper in the class, is a female, then this is equal to 1. And the top performer in the class, if the top performer in the class is a male student, then this is equal to 0. So the coefficient of interest here is beta. And we control for student-specific characteristics through this X vector. And then we have classroom-specific characteristics, which we control through this W vector. Further, we have school year-specific fixed effects to control for any unobserved confounders at a school cohort level. And we have the errors. So what are our outcome variables? We consider several outcome variables. And first is that we consider the performance in mathematics and language in grade 10. And then we consider the track specialization choice in grade 11. This is again similar to the field that you choose in A level. One thing I want to mention compared to Sri Lankan system to Greek education system is that there's no minimal requirement to choose any track. So anyone with any prior qualifications can choose either science, IT, or classic without any restriction. Then we consider long-term effects, which are whether the student applied for a STEM university department, or whether they get enrolled in a STEM university department, and the quality of the department that they enrolled in. On top of it, we consider are the students like to imitate their top performer, like do the same thing that their same gender top performer is doing, or are they not likely to imitate their top performer? Well, I'm not going to present any tables or results as is, but I will summarize the results that we find. So what do we find? Same gender top performers, they improve female students' performance in STEM by 0.2 standard deviations. As I said earlier, we estimate the effects for males and females separately. So basically, when we are interpreting our beta here, what we consider is, what we interpret as is that what is the effect on females who are having the same gender top performer compared to those females who are having an opposite gender top performer. Or in other words, the effects for females if they have a female top performer versus male top performer. We don't compare between males and females. So when we are estimating, we drop the top performer and focus on the rest of the students. Like, what is the effect of the gender match of the student and the top performer on females? And then we consider the same thing for the male students, but separately. So we see that females perform better in STEM, which we proxy by the mathematics performance, by 0.2 standard deviations if they have a same gender top performer. But we do not find any effects on their language performance or non-STEM performance, which generally considered that females are good at. One thing I want to emphasize earlier as well, that there's a norm that females are not good at math, but in our data, as well as in many other data sets, it's shown that females are actually not bad at math. It's that they're comparatively better in language, but they're good at math as well. And then in terms of likelihood of choosing the STEM track in grade 11, where that they make the first decision on what to specialize in, they are more likely to choose a STEM track in grade 11 if they have a same gender top performer compared to an opposite gender top performer. Further, they are more likely to choose a STEM track, STEM university degree, and enroll in a STEM university degree as well. Again, this is a bit different to Sri Lankan system. In Greece, they can apply to any university, but they have a weighted average system, how they are graded to like the university cutoff, but they can apply to other degrees as well. And in terms of the quality of the university, female students with same gender top performance are more likely to apply for more selective universities, or more specifically the top universities, or the universities within the top 20% in the Greek university system. So this increase is by 0.9 percentage points. So this first set of results are just considering whether you have a same gender top performer or an opposite gender top performer. We did not consider what the top performer is really choosing there. But then, as a mechanism, potential mechanism, we check whether the students are more likely to imitate and mimic their same gender top performer. And yes, females are more likely to mimic their top performers' choices if their same gender top performer is choosing a STEM track. In generally, if we can say that when the top performer or the same gender top performer is choosing a gender dominated track, then females are more likely to follow their top performers' decisions. Well, throughout this research, I was talking about females and effects on females. What about males? Do they have any effects? Well, consistent with most of the existing literature, we do not find any significant effects on male students. That means their performance or preferences towards STEM does not change with the gender of their top performer, whether they have a same gender top performer or an opposite gender top performer. Well, I think I'm quite fast than expected. So I will directly jump into the conclusions and implications. Well, summarizing the results, we saw that same gender top performers improve female students' performance as well as preference towards STEM fields. And we don't find any effects on male students. It is really important to have salient recognition to have this role model effect. So I told you that in this Greek high school system, the one who acts as the monitor or the record keeper, the one who takes this record book to the teacher several times a day, every day, is the one with the highest score, highest average score. So the second top performer or the third top performer, they are not recognized by the others because they don't go to the teacher and they are not recognized. And because this is by law, when the students see the record keeper, they know that this is the top performer, not anyone else. However, to validate this one, we undertake a series of placebo exercises and simulation exercises to understand what about the second top performer, third top performer, or any other high performer, or the top performers in other classes, like several exercises to understand the mechanism. But since the top performer is the one who's receiving this salient recognition, only the top performer has role model effects. So any other high achievers who are not top performers, who are not recognized, do not have role model effects in our data set. In conclusion, we can say that same gender peer role models can reduce the underrepresentation of qualified females in STEM fields by about 6%. So by being here, doing STEM careers, studying in STEM, you can act as a role model. So you're doing a great work. And I want to say that keep up the good work and try to motivate all the females to be in this field. And that's the end of my presentation, which is quite fast. And thank you so much. And if you have any questions, please feel free to ask. And it's highly welcomed.
Yeah, thank you so much for that enlightening speech, Bhagya.